Welcome to The Explainer. Honestly, I am so pumped you're joining me today because we are looking at an absolute watershed moment in technology. For the longest time, the narrative has just been accepted, right? The most monumental, industry-shaking AI models are firmly locked away in massive corporate server farms. But today, we're focusing on how those exact models are finally making it directly to local home setups. We're going to see how the brand new Qwen 3.8 family, teamed up with just an incredible breakthrough from Unsloth, is fundamentally rewriting the rules of what your personal computer can actually do.
I mean, it sounds completely ridiculous, right? Can you run a 2.4 trillion parameter AI on your home computer? Just think about the sheer scale of that for a second. We are talking about a Goliath-sized modern AI, a system built to rival the absolute frontier of artificial intelligence, matched up against the David-like hardware sitting right there on your desk. Until very recently, the answer to this was a hard, undeniable no. The tension between the massive size of these models and the limits of consumer hardware just seemed completely impossible to overcome. But the landscape has shifted, and the answer is changing right before our eyes.
Okay, so here's our roadmap for today. 1. Meet the Qwen 3.8 family. 2. Shrinking giant AI models. 3. Hybrid thinking and reasoning. 4. Running Qwen 3.8 locally. And 5. The benchmark proof. Don't worry about the heavy math, we're going to keep this super straightforward.
All right, let's dive into this. Section 1. Meet the Qwen 3.8 family. Introducing the 27B and 2.4T Titans. Specifically, we are going to focus on the two standout models that are completely changing the game for local deployment. The sheer scale and capability here is just staggering. On one end, you have Qwen 3.8-27B. It's a 27 billion parameter model packing native vision capabilities, deep reasoning, and a massive 256K context window. Then, on the extreme other end, you have the Titan Qwen 3.8-2.4T-95B. This is a 2.4 trillion parameter beast that is actively rivaling GPT-5.6 Sol, which is literally the bleeding edge of AI right now. Both models feature developer role support, making them incredibly good at using agentic tools, so they can take independent actions like executing code, and they're MTP-enabled, which structurally optimizes them for blazing fast inference.
Moving right along to Section 2, Shrinking Giant AI Models. The Unsloth compression breakthrough.
So this brings us to a central dilemma. How on earth do we fit a giant model onto standard hardware? To really understand Unsloth's breakthrough, look at this comparison. On the left, if you wanted to run the full precision uncompressed version of the 2.4T model, you'd need 4.9 terabytes of storage. And that's just to store it. Never mind loading it into active memory. It's an impossible requirement for almost everyone. But then on the right, using Unsloth's new 1-bit dynamic GGUF format, that exact same model shrinks all the way down to just 397 gigabytes. Think of this extreme quantization like vacuum sealing a giant suitcase. You are fundamentally altering how the data is packed so you can fit a frankly absurd amount of intelligence into a drastically smaller footprint.
Yeah, that is a 91% reduction in physical size. 91%! Unsloth achieves this by pushing the absolute limits of math, utilizing new 1.1875 bits per weight data types. They've essentially figured out how to strip away the structural fat of the neural network without lobotomizing the core intelligence of the model. It is just a stunning engineering achievement.
But let's bring this down to earth for a second and look at the highly accessible 27 billion parameter model. If you have an RTX 4090 desktop GPU or a Mac with 24 gigabytes of unified memory, you can run the highly capable 4-bit version of Qwen 3.8 27B right now, today. It only requires 17 and 19 gigabytes of combined RAM and VRAM. The uncompressed model, that would require 56 gigabytes. By squishing the model down, top-tier AI is now sitting comfortably inside standard consumer-grade laptops and gaming rigs.
Which leads us perfectly into Section 3. Hybrid thinking and reasoning. New architectures for smart models.
Okay, so now that we know we can physically fit these models on our computers, we really need to look at their unique cognitive architecture, because we are moving way beyond just raw hardware specs and parameter counts here. The absolutely crucial point is a new feature called preserved thinking. You see, typical large language models are somewhat forgetful. They process your prompt, give an answer, and essentially start completely fresh on the next prompt. But Qwen 3.8 can actually leave the thinking trace from a previous conversation intact. This acts as an ongoing memory. It increases the tokens used, sure, but it dramatically increases accuracy in continued, complex, multi-step chats, all because the AI doesn't lose its train of thought.
And this brilliantly illustrates exactly how deep this cognitive architecture goes.
Qwen 3.8-27b is a hybrid model, meaning it requires completely different inference settings depending on its current task. When it's in thinking mode, tackling a really complex problem, the temperature and top P are dialed up to 1.0 and 0.95, allowing for wider, more creative reasoning paths. But if you switch it to instruct mode for simple, direct tasks, the settings drop to 0.7 and 0.80, forcing it to be precise and highly focused. It's an AI that actually shifts gears based on the mental effort required.
All right, Section 4, running Qwen 3.8 locally, from breakthrough to application.
This right here is the highly actionable part of our explainer. We've talked about the theory, the math, and the architecture, but how do you actually harness this power on your own machine today? Look, it used to be that running local AI required a PhD in command line syntax and Python environments. Not anymore. To run this today, you just download the Unsloth Desktop app. It works natively on Mac OS, Windows, or Linux. You open it up, search for Qwen3.8 in their built-in model hub, and you click Run. Literally, that's it. Unsloth automatically configures all those complex inference parameters like temperature and top P that we just talked about. It makes the setup process incredibly accessible.
What makes the Unsloth Desktop app so incredibly powerful is that it acts as a complete, out-of-the-box, open-source AI ecosystem. Under the hood, it automatically offloads processes to your system's RAM and seamlessly detects multi-GPU setups if you have them. But on the user end, it enables self-healing tool calling, live web search, and even built-in code execution for Python and Bash. It leverages MLX and llama.cpp for incredibly fast inference whether you are leaning on your CPU or your GPU.
And hey, if you happen to be on the absolute cutting edge of hardware, there is an extra gear here. For those running the latest NVIDIA Blackwell GPUs, like the new RTX 50X series, Unsloth offers NVFP4 quants. This specific format allows you to run the Qwen 3.8 27b model 1.5 times faster than standard uncompressed checkpoints, squeezing massive throughput out of just 24 gigabytes of VRAM. It's a pretty remarkable optimization for top-tier machines.
Finally, Section 5, the benchmark proof. Did extreme compression ruin the intelligence?
We really have to address the skeptic's obvious question here. Did vacuum sealing a model by 91% destroy its brain? Does extreme compression ruin its actual ability to think, reason, and code? Well, the definitive answer lies in the Qwen Pro score, which is one of the hardest agentic coding benchmarks out there. Notice how our heavily quantized Qwen 3.8 27b model scores a massive 61.7. It soundly beats its predecessor, Qwen 3.6, but way more importantly, it beats massive frontier models like Opus 4.6 Max, which scored a 53.4. So no, the intelligence is absolutely not ruined, it is thriving.
In fact, across rigorous testing over multiple domains, including code, chat, and scientific reasoning, Unsloth's compression miraculously retains 92 to 97% of the original uncompressed model's accuracy. Even when using those hyper-fast NVFP4 quantizations we mentioned, the model stays incredibly sharp. You are losing almost zero practical intelligence, but you're gaining near universal local accessibility.
Which leaves us with this final thought. We are currently sitting at a point where a 2.4 trillion parameter model can be mathematically compressed to fit on high-end local hardware, and 27 billion parameter agentic models can run natively on standard MacBooks. If this is what we can do today with these staggering Unsloth breakthroughs, what on earth is local AI going to look like next year? The power dynamic of technology is shifting straight to your desktop. I really hope this explainer gave you a clear map of how we got here. Now seriously, go download the app, load up Qwen 3.8, and start experimenting for yourself